these are the step-by-step answers for the series multiple choice practice test 2. Let's get started. What is the value of this infinite series? Since we have, we can simplify this series function here. Properties of exponent says we can separate that 3 to the power of n plus 1 into this. This is going to equal to 1/3 over 2n over 3n, which gives us a common exponent, so we could rewrite it like that. And since this is an infinite series and this is geometric, we're going to use the infinite sums formula. Remember that there's two formulas for geometric series. It's s of n and s of infinity. So s of infinity is a over 1 minus r, and s of n is a, let me write that, a 1 minus r to the n over 1 minus r. We're not going to use this one since we are using infinite series, and that s of n series is solving for a specific term. So we're going to apply this formula. A is our first term, so let's plug it in. So 2 to the 0 over 3 to the 0 plus 1 is just going to be 1/3. So 1/3 over 1 minus r. Our r is our ratio, which can be found in the parentheses here when it's put to the power of n. So this is going to be r. So it's going to be 1 minus 2/3. 1/3 over 1 minus 2/3 is just 1/3 over 1/3, which is just equal to 1. And your answer is B. Question 2 says you are given the arctangent Maclaurin series and a infinite series function. We just need to find the power series expansion. So for questions like these, I like to do the expansion individually. So first, we need to list our memorized arctangent function, which is, looking at the terms here, I believe they only got to the first 4 terms. So it's going to be 1 plus x squared plus x cubed. And then our first change is this plus, and then there's this minus here. So what we need to do first is make that alternate. So it's going to equal to 1 minus x plus x squared minus x cubed. Why we start with subtracting instead of adding, then subtracting first when it alternates, is because I just memorized this because of the cosine and sine series functions, in which they always start alternating by subtracting first, then adding, and then so on. So that's how I got that. Oh, it's supposed to be plus x. Now we're going to square that. So what that means is we have to set all of these times, we have to square all of these functions here. Remember that one is x to the 0, but that won't really make a difference for this series here. So x to the 0 squared is just x to the 0, which is 1. X squared is just x squared. X squared squared is x to the 4th, and x cubed squared is x to the 6th. Remember that this is part of your properties of exponents, so this should be expected for you to know. And then now we're going to multiply x cubed into our expanded arctangent power function, which is basically that. So we're going to multiply x cubed into every term here. So it's going to be x cubed, let me write that down, times x cubed times x cubed times x cubed times x cubed. So it's going to be x cubed minus x to the 5th, because properties of exponents in Algebra 2 says that when you multiply exponents with the same base, those exponents add together. So x to the 4th times x to the 3rd is just going to give us x to the 7th, and then that's going to be x to the 9th. And this is your power series expansion, which that matches with question or prompt. No. D. Alright, this concludes question 2. We're moving on to question number 3. A function f has Maclaurin series given by this set of series. We need to find an expression for this. So that we know that this is sine of x because our factorials, not all the factorials are here, and they're all odd. I always think of sine as the odd one when it comes to memorizing the series. So this is another expansion. So we need to discover which expansion it is. Sine of x is equal to 1 minus x cubed over 3 factorial plus x to the 5. How many terms is that? It's 4. So it's 5 factorial minus x to the 7 over 7 factorial. So what this does first is this alternates in reverse. So it's going to be sine of negative x, which gives us negative 1 plus x cubed over 3 factorial minus x to the 5th over 5 factorial plus x to the 7 over 7 factorial. That matches up with the first 4 terms so far. What is next? So we are going to, what I notice here from negative x cubed and negative 1 is that all we did was multiply x squared to get negative x cubed. So that's what we're going to do. We're going to multiply by negative x squared. So it's going to be, oh no, not negative, positive x squared. Since we have that negative inside the x, that makes it alternate in reverse. So it's going to be x squared sine of negative x equals negative x squared. Remember that these terms, these x's add each other because they have a similar exponent. Oh wait, this is x cubed. X to the 7 over 5 plus x to the 9 over 9. Oh, not 9, 7. And does this match the above terms? Let's check. Yes, it does. So our answer is going to be C. Number 4 says that what are all values of p in which the infinite series converges? So we're trying to find, this is a p series. And it converges when x is greater than 1. So we can simplify this infinite series here. A little trick, remove that 1 since that is represented as n to the 0. And that won't really do much for our future problem. And as Mr. Rodriguez likes to say, if you had a bank account filled with $1 million and you add an extra dollar in there, it doesn't make a significant difference. And that's true regarding this one here, so cross that off. We're not going to use that. Which gives us n over 2 times n over p. And which we can rewrite that properties of exponents, n over p times n to the negative 2, since they share the same base. They both add, but in this case it subtracts. So not x. When p series converges when your p value is greater than 1. So we need to find p minus 2 is greater than 1. So it's going to be p is greater than 3. Your answer is going to be D. Moving on, question 5. Which of the following series converges? This is a geometric, and it converges when it is less than 1. Yeah, so let's see. Root 2 over cosine of 1. Since cosine of 1 is bounded between 1 and negative 1, that's just going to be 1. Root 2 is greater than 1, meaning that this does not converge. It diverges. 1 over n to the power of 1/2. This is p series. And it converges when p is greater than 1. 1 over root n can be rewritten as 1 over n to the 1/2. Our p is equal to 1/2. It is greater than 1. Less than 1. So it does not converge, it diverges. So 3. Remember that this is another p series, similar to how we did the problem before this problem. We can rewrite this as 1 over n3 minus times n to the negative 1. And that's going to be 1 over n squared, which is p is greater than 1. So that converges. So it's just going to be 3 only, which is C. Number 6 is, what is the coefficient of x cubed in the Taylor series for 1 over 1 minus x cubed about x equals 0? So this is another arctangent power series expansion. So it's going to be 1 minus x. It's asking to derive 3 times, or to go until the third degree. So I'm just going to go to that. 1 plus x squared plus x cubed. And with that expansion, all we need to do is cube everything. So remember that 1 is x to the 0. And now we're going to cube it. Everything is going to be cubed. So it's going to be 1 plus x cubed plus x to the 6th plus x to the 9. So what is the coefficient of x cubed? It's going to be 1. Our answer is A. Question 7. What is the approximation of the value e to the 1 obtained by using the 4th degree Taylor polynomial? So what this is saying is that we have the e to the x polynomial here. So this is the memorized series, as you guys should remember. It is asking for the 4th degree. And then all we need to do is change it to e to the 1. So it's going to be 1 plus 1 plus 1/2. We're just going to replace all the x's with 1. So boom, 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 boom. This is going to be really easy. The only thing that's going to change is the denominator because of our factorials. 3 times 2 is 6 times 1, that doesn't do anything, plus 1 over 4 times 3 times 2 is just going to be 24. And number 7 says that we need to approximate these terms, which combined like terms is going to be, we have a 2 in the front, meaning that B is our answer. I just simplified those factorials. You can check if you want, but it should be correct. Number 8, which of the following series diverge? This is another geometric series right here, and it diverges when r is greater than 1. 3 over 2.718 is greater than 1, so this does diverge. This sign is a switcher, meaning that it alternates, and alternate series always converges. So number 2 is out. And then number 3, 10 to the power of n, that's just basically 1 over n to the p, which p is just 1. This is a harmonic series. and harmonic series always diverges. So our answers are going to be 1 and 3, which is C. Question 9. For what positive integer k will both this and this converge? Let's start with this. This is a geometric series again. And remember that geometric series converges when it is less than 1. So we're going to find our k value for this. Multiply both sides by 2. 5 minus k is less than 2. Minus 5. Minus 5. Wait, that doesn't cross out. K is less than negative 3. Divide by negative. K is greater than 3. And then for this is a p series. P series converges when p is greater than 1. So subtract. And then negative k is less than. Whoa, where did it go? I am on the wrong part. Okay, back to this. K is greater than negative 5. Divide by a negative. K is less than 5. So k is greater than 3 and k is less than 5. Our answer is going to be 4. Because that lies in between those two borders. Alright, what is the approximation for sine of 1 obtained by using the 5th degree Taylor polynomial about x equals 0 for sine of x? Sine of x, that polynomial is going to be 1 minus x cubed over 3 factorial plus x to the 5th over 5 factorial. So it's going to be sine of 1 equals 1 minus 1 cubed, which doesn't do anything, over 3 factorial plus 1 over 5 factorial. So that answer is going to be D. Then moving on to this. This is the ln function. And we're trying to find the 2nd degree Taylor polynomial for f for about x equals 2e. So we're going to derive this twice since it's asking for the 2nd degree. Meaning our formula will look something like this. F of x times x to the 0 over 0 factorial, which does absolutely nothing, plus f prime of x times x over 1 factorial, that also does nothing, plus f double prime of x times x squared, which gives us 2 factorial, which is 2. The reason why I wrote this formula down is because it originates from this. F of x times x minus c to the n over n factorial. We don't have a c value. Let's just assume c is 0. So, yeah. Now we need to derive f of x 2 times. So f of x equals ln of x minus e. The derivative of that is 1 over x minus e. And then the 2nd derivative of that, that one you guys can figure out, is going to be negative 1 over x minus e squared. And then now we're trying to evaluate that at x equals 2e. So f of 2e, you guys can algebraically solve that. That's just going to be 1. F prime of 2e is 1 over e. And f double prime of 2e is equal to negative 1 over e squared. What I basically did and why I skipped these steps is because this is just a flashback to derivatives, which BC students are expected to know. I just plugged in 2e for all values of x, and that's what I got. So it's going to be f of 2e that's just going to give us 1. So we're going to replace this with 2e, 2e, and then 2e. Oh, x is 2e, so x minus 2e. Apologies. So it's supposed to be x minus 2e, x minus 2e, and then x minus 2e squared. Alright. But still, this does nothing for the first function. So f of 2e is 1 plus f prime of 2e times x minus 2e. F prime of 2e is, what was it again? Is 1 over e. And that's x minus 2e plus, wait, no, it's minus 1 over e squared times 2, because of that factorial, x minus 2e squared. All I did was plug in everything into the Taylor formula. You guys are expected to know that too. Which answer choice matches with mine? It's going to be B. So B is our answer. 12. The sum of the infinite series is. So it's going to be, we're going to use the geometric formula since this alternates. Interesting. So this is an alternating infinite series. A equals 1 minus r. Lucky for us, we got our A. And then our r, you can solve that by doing negative. Remember that it's going to be our second term divided by our first term. But if your series is starting at 0, it's going to be a of 1 over a of 0. So how we can apply that is 36 divided by 1 minus, what is negative 12 over 36? That's just negative 1/3. Which the keep, flip, change method. So it's going to be 36 over 4/3, which is reciprocate. That is just going to give us 9 times 3, which is 27. And that is A. Question number 13 is, consider this series right here. If the ratio test is applied, oh, that's a big help. Which of the following inequalities results implying that the series converges? So we're going to solve until we get one of these answers here. Remember that our ratio tests, you guys need to remember this as well, is limit as n is approaching infinity. Oh, yikes. A n plus 1 over a to the n. So let's plug that in. Since we're dividing fraction by fraction, we can just rewrite that as a reciprocal. So it's going to be e to the n plus 1 over n plus 1 factorial times n factorial over e to the n. And then we can rewrite this as e to the n times e to the 1 because of properties of exponents from algebra 2. So it's going to be e to the n times e to the first n plus 1 factorial times n factorial over e to the n. These cancel out. giving us, we can expand this, equals n plus 1 times n factorial. That's a little trick that you guys should have known when Rodriguez was lecturing on ratio test and how to do factorials. Yeah, e times n factorial over n plus 1 times n factorial. Those n factorials cancel out, leaving us with e times limit as n is approaching infinity. Wait, I did all the dirty work for nothing. We could have just found out the power series expansion, which is b, and why it's b, because it always converges when the product of your ratio test or your quotient is less than 1, and this is basically that. Okay, that concludes question 13. I was about to solve the whole thing. Number 14, which of the following series diverges for all real numbers x? Looking at this, you can simply apply ratio test to all of this. It's going to take quite a little bit of time, but it's pretty fun. So A, let me highlight that. Let's highlight that yellow. So we're going to solve that in yellow. A, let's apply ratio test. So that's going to be x to the n plus 1, which is equal to x to the n times x. So let's rewrite that. I want to reserve space. You could do all the work that I just did above. So that's fine. N plus 1 plus 1 is just factorial is just n plus 2 factorial. So it's going to be something like that. And we know that we're going to reciprocate times the a to the n. So we're just going to use the same thing, but flipped. We can cancel those. And n plus 2, remember that memorize the strategy of factorials is n plus 2 times the sum of all terms before that. Alright, take note of that. And let's replace that with n plus 2 times n plus 1 factorial. Those cancels out. So it's going to be x times 1 over n plus 2. This is laggy a little bit. Limit as n is approaching infinity. That's going to be 1 over infinity, which is just 0. So 0 is less than 1, meaning, actually I'm going to write that down. Infinity, 1 over infinity equals 0. So it's 0 times x. And 0 is less than 1, so this one converges. So this is out of the game. So next one is this. Boom. Boom, boom. And then we're going to apply ratio test. Alright, I'm not gonna do the entire math here since you guys should be doing this mentally, and this is pretty simple. So we're gonna simplify that. Limit n is approaching infinity is n squared over n plus 1 squared. which is just infinity over infinity, which that equals 1 in this scenario. For L'Hopital's rule, that is indeterminate, but for this it's 1. X must be less than 1. And it's asking which of the following series diverges for all real numbers x. So that one converges. Since it's anything that's less than 1, it converges, and it cannot be all real numbers. It has to be all real numbers, so this does not apply. Let's move on to this. C. Now let's solve that. N minus 1. N minus 1 plus 1 is just going to be n factorial over 5n times 5 times x to the n times x. I did all the algebra in my head. You guys can do the whole thing if you want. Pause the video, and I think you should get to where I'm at right now. Anyways, for those of you that are finished or did the same thing that I did, you should be back. You should be at my place right now. So let's do the cancel party. Boom, boom, boom. What's left is it's going to be limit as n is approaching infinity is going to be n factorial over times x over 5 n minus 1 times n factorial. Properties of factorials, that cancels out. We can factor out that x over 5 and that's going to give us 1 over n minus 1, which when we apply the limit as n is approaching infinity, that's going to be 1 over infinity, which is 0. But hold on a second. This was supposed to be the answer according to the solutions. I don't know if I did the algebra wrong. Oh, I did do it wrong. Yeah, I did do it wrong. My bad. The factorial, I did the factorial properties wrong. So here's how it's supposed to look like. So we canceled out those x's, so it's going to be n factorial n factorial is going to equal, why is it so laggy? Boom. So that's what we're going to do. Yeah, this is why you guys should know your properties of factorial, so that way you don't make the same mistake as me. So that's going to be x over 5 times limit as n, not x. N is approaching infinity. It's going to be n, which that's just going to be infinity. And infinity times x over 5 is going to be infinity. And you know that infinity is divergent. So our answer is going to be C. you could test those other ones, but you'll get x is less than pi and x is less than e, which is not all real numbers. Infinity is all real numbers. So that concludes question number 14. Number 15 is, what are all values of x for which this converges? So it's going to be x minus 1 over 3 is less than 1, and the opposite of that x minus 1 over 3 is greater than negative 1. This is similar to solving for the radius of convergence after solving for the ratio test. So that's where I got the less than 1 and greater than negative 1 from. And that is also a geometric series property. So let's solve for this individually. Times 3. So it's going to be x minus 1 is less than 3 plus 1. So x is less than 4. Let's apply the same algebra here. So it's x minus 1 is greater than negative 4 plus 1 plus 1. X is greater than negative 3. Oh, wait. No. Not. Sorry about that again. I am messing up today. It's negative 3 plus 1, which is 2. So it's going to be negative 2 and positive 4. Where do we see that in our answer key? That's going to be C. 16. What is the sum of this series? So let's see. This is another power series expansion. And looking at this is an alternating series, but for some reason we have all the terms here. So it's going to be an e to the x series. Equals 1 plus x squared over 2 factorial plus... Oh, wait. Oh, no. We can just write up to x squared. Okay? What we can do here... Oh, it's going to be e to the negative x, since it alternates. So it's 1 minus x plus x squared over 2. Is this correct? Yes. Our negative and positive are on the same places, so that we're on a good track so far. And we replace x with ln of 3. So e... Why is it not drawing? To the negative ln of 3. Well, we're going to replace all x values with ln of 3. Is this correct? Yes, it is. So now we can look at this, and knowing our properties of logarithmic functions, we can put that negative on the power of 3. So e to the ln cancel out, which gives us 3 to the negative 1. And 3 to the negative 1 is just 1/3. And that answer is going to be D. Alright. So 17 says, which of the following series is Taylor series for f when it is about x equals 0? So this is going to be a little bit tough, but not too tough. So here it's going to be sine of x. Memorize this. Alright. Then sine of 2x. Yeah, my bad, that's really laggy. So we're going to multiply everything by 2. 2x. 2x cubed is going to be 8x cubed over 3 factorial. And then 2x to the power of 5 is 32x to the 5th over 5 factorial minus 2x to the 7th power is 128 to the x to the 7th power over 7 factorial. And now we're going to divide by 2x. It is so laggy. Okay. We're going to divide everything by 2x. 2x divided by 2x is going to be 1 minus 8x cubed divided by 2x times 3 factorial. Oh, let's leave that factorial alone since none of those answers simplify that factorial, thankfully. So it's going to be 8 divided by 2, which is going to be 4. And then x cubed divided by x squared. Divided by 2x. Divided by x is going to be x squared. 32x to the 5th divided by 2x. 32 divided by 2 is 16. And x to the 5th divided by x is just going to be x to the 4th over 5 factorial. Let's not forget those factorials at the bottom since they help us find our answer. 128 divided by 2x. 128 to the x to the 7th divided by 2x is going to be 64x to the 6th. So, boom. Divided by 7. Which answer matches that? That answer is going to match B. Moving on to question number 18. The graph of the function represented by the Maclaurin series with this function here intersects the graph of y equals x cubed at x equals. So it's going to find an intersection. This is going to be the cosine series. There's no changes, thankfully. And then we're going to set that equals to the y equals x to x cubed. And we're going to find the intersection. The intersection is going to be at 0.865. Graph that at your TI-84 calculator using the y1 equals cosine of x. Then the y2 equals x cubed. Press graph. Then find the crossing point. Then second trace 5, which is the intersection. Then go a little bit beyond the intersection point of those two graphs and estimate it, and you should get 0.865 or rounded 0.866. If you're one decimal place off, you're probably on the right track, which is good. So our answer is going to be B. If the limit from b to infinity for this series is infinite, which of the following must be true? This is an integral series test where there's 3 cases. Case 1, is your f of x positive? Yes. Is your f of x continuous? In this case, yes. And in this case, is the derivative less than 1 or less than 0? Yes. Why? Because 1 over x to the power of p, when you derive that, that's going to be 1 over x to the negative 2p, which is going to be it's a negative function. So yeah, so let's write that down. Our first case is f positive. Our f of x is going to be dx over x over p, or it's going to be 1 over x to the p. That's going to be a yes. There's no negative so far. 2, is it continuous? We can assume yes because it goes to infinity. Then 3, is the derivative less than 0? Let's find that derivative. That's going to be negative 1 over x to the 2p. So it is. So anyways, that integral test was useless. Sorry about that. I was just trying to explain to it for you guys for the test. Which of the following must be true? If this is the case, then your sum, your series must be divergent, because diverge means going to multiple destinations, which is infinity. So it's going to be B. Why it's not x to the p plus 1? It doesn't match with the function given to us in the problem. So it's basically just like a applying knowledge sort of question. Okay, moving on to question 20. If this is a Taylor series that converges to f of x for all real x, then f prime of 0 is. So this is basically saying, what is the second degree? And since this is a alternating function, which includes all terms, this is going to be an e to the negative x. Why this is the case is because we have all the listed terms, so it cannot be sine of and cosine of x, and it cannot be the arctangent because there's no factorials on the bottom. This must be the e to the x, but it alternates, so it's going to be e to the negative x. So what we're going to do first, since it's asking for the second degree, or f double prime, we're going to derive that. So our first derivative for e to the negative x is going to be negative e to the negative x. Then we're going to derive that again, which is just going to be e to the negative x. So it's e to the negative 0 is just 1, because anything to the power of 0 is 1. So our answer is going to be B. Very, very simple. For 21, what are all values of x for which this series converges? So this is, we're gonna, since we're having this weird thing right here, we're gonna apply ratio test. But remember that switchers do not go in your ratio test quotient. So what we're going to do first is I'm just gonna write down how to do the ratio test terms. This is gonna take a little bit for me though. This is gonna load a little while. It's pretty laggy. Okay. X minus 2 to the n times. Why is it so slow today? Times x minus 2 over n plus 2 alright, and then now what we're going to do is we're going to multiply by the reciprocal, which is just n plus 1 without any adjustments, over x minus 2n. Cancel party, and that just gives us x minus 2 times limit as n is approaching infinity. That is a horrible arrow, sorry about that. N plus 1 over n plus 2. Which gives us infinity over infinity, which just gives us 1. Okay? And remember that when we solve for the radius of convergence, or our convergence or divergence points, it's going to be x minus 2 is less than 1, and x minus 2 is greater than negative 1. How about I close this and see what happens? It'll become less laggy. Okay, let's write. Kind of helped. Okay, plus 2. X is less than 3. And x plus 2. X is greater than 1. Well, we're not quite done yet. We're going to check if there's a less than or equal to. So, what this means is that we're going to plug in x equals 3 and x equals 1 into our function here. So let's put it 3 minus 2 over, that's going to be negative 1 to the n times 1 to the n over n plus 1. So that's still going to be an alternating series, which does converge. So it's going to be x is greater than or equal to 1. Let's check the other one. Why is it not erasing? There we go. It is so laggy. Okay. Let's see when x is 3. 3. Whoops, I did not mean to write that there. 3. So it's going to be -1. Wait a minute. Oh, I saw. Did I put 3? No. 3 was supposed to be less than or equal to. And then I plug in -1 for x. So it's going to be -1. Oh, +1. -1 to the n times -1 to the n over n plus 1. That's going to give us 1 to the n over n plus 1. This is a p-series, or no, this is a harmonic series, which always diverges. So it's not going to be x is greater than or equal to 1. It's just going to be x is greater than 1. Since we must have it converge. All right? So let's see. Our answer is going to be C. All right? Moving on. We have 2 more pages left. We're almost there. All right. Let p of x equals that be a third degree Taylor polynomial for a function x equals 0. What is the value of f double prime of 0? So Taylor, remember Taylor that it's going to be f, we're trying to find f double prime of 0, so it's going to be f double prime of 0 times x minus 0 squared over 2 factorial is equal to 6x squared. Third, I don't know why it says third degree Taylor polynomial when we're not really using anything involving 8x cubed or deriving something 3 times, but I guess they mentioned that so that they could trick you and that you need to know what you're solving for. Okay, back on track. All we need to worry about is the value. So basically, what is the coefficient, or what is the number? So we're going to multiply that by 2, not the highlighter, 2. 2 over 2 factorial is just 2 anyways. So yeah, 6 times 2, that's going to be 12. Ignore the function since we're solving for constant. That's just going to be a. What are all the values of p for which this converges? Very easy. It's p series, so p must be greater than 1. Subtract that by 1. It's going to take a little while to load. 0, 2p is greater than 0. Divide both sides by 2. P is going to be greater than 0. 23. 24. Another property here. If 1 to infinity f of x diverges, which of the following is true? Well, if this is the integral test. So if the integral diverges, that means the series must diverge. That's another application of knowledge towards your vocabulary and properties of series and tests here. So there's no mathematical explanation for this. So for 25, if this series converges and this is the domain, which of the following statements must be true? Well, we can't have any divergent answers here since this, the series converges, and a of n could possibly be equal to b of n. A of n also converges then. Why? That is because they have a similar relationship, so they have a like property. It doesn't alternate. it never says that A of n alternates, so those two do not apply as well. Last question. Let f be a function with these values, which the following is the third degree Taylor polynomial for about x is less than 3. So we're trying to find the whatever this formula again. F triple prime. Is it triple? Yes. Oh, wait. We have to solve for the whole thing. Whoops. So it's going to be this long process again. F of -3 times x plus 3, 0. I'm not going to put the 0 factorial. It's too laggy. Plus f prime of -3 times x plus 3 over 1 factorial. Once again, you don't need to put that. F double prime of -3 times x plus 3. Write it down. Over 2 plus f triple prime of -3 times, oh my gosh, this is really laggy, x plus 3 cubed over 3 factorial, which is just going to give us 6. All right, plug everything in. F of -3 is -1 plus f prime of -3, which is 2, times x plus 3. Plus f double prime of -3, -12 over 2 times x plus 3 squared. Change color. So that's going to be 6. Plus f prime of -3, which is 72 over 6 times x plus 3 cubed. Okay. 72 divided by 6. That's going to be 12. Alright, that's our answer. So which of the following matches that? Our answer is going to be C. Alright. Thank you guys for watching. This concludes the part 2 practice test of the series. It is late for me, so sorry if I got some of those questions wrong and I had to redo the whole thing. But I wish you guys good luck, and make sure to memorize your series, make sure to memorize your test, make sure to memorize every single one of those that I tell you to memorize, and you will do excellent on the test.